Hi, we're Team 5. I'm Jessica, a material science and engineering major.
I'm Sequoia. I'm a computer engineering major.
I'm Stefan Laborde. I'm a civil and environmental engineering major.
I'm Nadalyn Soto. I'm an aerospace engineering major.
And the problem that we're addressing is adapting to air pollution caused by industrialization.
So with the increase in industrialization, we've had to grapple with the effects of the increase in air pollution and decrease in air quality. This is the Vistra Martin Lake Power Plant in Rusk County, Texas. It is considered to be the worst polluter of sulfur dioxide in the nation. In 2010, a study was commissioned by the Clean Air Task Force, a nonprofit, to analyze the effects of coal power plants in the U.S. It found that annually, the Rusk County Power Plant was attributable to 42 deaths per year, valued at around $310 million. Additionally, these emissions have resulted in increased levels of smog, asthma, and cancer rates in the nearby population. Considering that from 2015 to 2018, the emission rate tripled, we can expect that these effects are only going to get worse. As the plant has been shielded from EPA action due to the Texas Air Board, we can assume that the plant will not be responsive to any effects or any attempts to increase and work on monitoring, and thus we have instead opted to go for a solution which targets the general populace, going for a discrete solution used indoors, able to monitor and contain and detect pollutants.
The intended function of our design is to remove any pollutants from the air. To do this, our design uses a gas sensor to detect any pollutants in the air. Currently, our gas sensor has a wide detecting scope and is able to detect many gases from nitrous oxides to ammonia to carbon dioxide. As can be seen by our model, which normally has a wall in front of those parts, but we have it open for clarity. We have a filter channel, which has the air filter, and a non-filter channel, which does not have the air filter. When a gas is detected, the fan is supposed to power on, and the servo motor moves the rotating plate to direct air only to the filter channel by blocking the non-filter channel. When the gas is no longer detected, the fan powers down and the rotating plate moves to block the filter channel. This way, our theoretical air filter is only used when we want it to be used.
The central testing component of the air filter is the sensor, since all the other parts revolve around the sensor working properly. To test its effectiveness, I conducted a two-sample t-test. To collect data, we used a random number generator to assign the order in which we tested the air sensor. Then we burnt a matchstick, which represented pollutants, by our sensor. Our random assignment of numbers is a center image, where odd indicates without and even indicates with matchstick. The raw data we collected and its graphical display can be seen in the upper and lower right side. Our two-sample t-tests, our null hypothesis was that there was no difference between the mean air quality with and without the matchstick. Ideally, we wanted to reject the null hypothesis and find evidence for the alternative hypothesis, which is that there is a difference between the mean air quality. After my calculations, we achieved that result when the t-value was greater than the critical value, thus proving that the air sensor is effective in detecting pollutants in the air.
In the future, we would like to expand our audience beyond the Texas power plant. We'd also like to expand the range of detectable pollutants. We also want to decrease the size of our filter in order to maximize its portability. Another thing we want is to ensure that our system is self-contained. And what that means is that air does not come in or out through any of the holes. One of the most important things that we think needs to be done is we need to keep the fan running at a low power state rather than just on or off. Thank you.
Thank you so much.